In this project video, I showed the ballistic experiments I conducted on 7075 aluminum, a lightweight metal that is a fantastic candidate for vehicle or personal armor. So let's get started. That's insane. That such a small piece. I really thought the 357 Magnum in a full metal jacket was going to yeet right through that. I really did. Hi everyone, and welcome back to the channel. So today we are discussing 7075 aluminum with the T651 hardness. This is a unique aluminum alloy that members of my Discord group have been wanting me to test, right? So this is kind of a labor of love for them. I purchased 10 of these sheets that are 6x6 and a 1/4 inch thick and conducted different ballistic tests on it, just to see what its threshold capabilities and that sort of thing are. And after testing it, I can honestly say, this would make a great candidate for vehicle armor. And it really might be one of the things that I end up using for the Jeep that I'm currently deconstructing and trying to armor up. If you follow this channel, you know what I mean. So expect another update with this, because now that I've shot it, I think we can get a little bit more out of this. So anyways, let's go ahead and get started with the video, guys. If you're new here, make sure to like, share, and subscribe. We are dangerously close to 10,000 subscribers. I'm really excited about that, and I promise something very special when that is done, once we hit that number. Alright guys, well, let's get started. So first up, we'll talk about how this grade of aluminum is different than other grades. I've got Devin, one of the mods on my Discord and our resident metal man, to help explain the unique properties that this grade of aluminum has. His accent can be a bit thick for those who don't speak Han. So I added subtitles and graphs to help represent and show you guys what he's going over. Really badly wants to be a tank, so this is the first time for him to be on on the channel. All right, you crazy French bastard. Can you give people a rundown of what 7075 aluminum is and how it compares to, let's say, 661, and the different grades, and why you were interested in this to begin with?
Well, the thing is, the difference basically between an alloy like most 7000 series and other series like 5000 and 6000 is mainly the chemical composition. The 7075 use mainly aluminum, of course, like all aluminum alloy, but the two main components added on top of it are zinc and magnesium. There are other one, of course, but in a lower quantity. For other stuff, like for example the 6000 series, it is mainly silicon, magnesium, and manganese that are added on top of the aluminum. So the chemical composition is the first thing that gives you a difference between the property of a different aluminum alloy. And then come the heat treatment. You have different kind of heat treatment available for most aluminum alloy. Generally, on most aluminum alloys, they are designed by a T followed by a number between 1 and 7. For various aluminum alloys, the higher the numbers, the higher the hardness, but the less ductility you have. So there is, if you want ballistic efficiency, and precisely that, there is a kind of balance to be found between how much hardness you can get, the maximum hardness you can get, before your mechanical strength begins to decrease, and before you lose too much ductility. There is a balance to be found about that.
Right.
And
yeah, well, and that's one of the interesting things now that I've already shot this, that really surprised me about it, and I guess it must be that hardness, is the fact that it wasn't very ductile. But so it either stopped the bullet right outright, like in the early ballistic tests with handguns, or it would kind of crack around the shot. And so that's an effect from the hardness, you're saying? So like the T65 or T651 hardness that I have, it's probably more because of the fact that it was hardened this way, that it was a bit more brittle, I guess you could say.
yes, it is because the T6 and the T651 are basically a kind of peak of mechanical strength for the 7075, which is where you get the maximum hardness you can get before your mechanical strength decrease. It is kind of the peak. If you get less, you get less strength. If you get harder, you get less strength. It is the peak. But it is a point where it is already kind of brittle. And when something goes through, you can see the failure mode, which is kind of brittle. You get cracking. You get even a bit of delamination, like on some kind of titanium. So it is kind of a peak. And
Nice.
this is what makes the 7075 in its T6 and in its T651 treatment one of the best aluminum alloy for stopping bullets. It's because it has, compared to other aluminum alloys, uh, high hardness and a high strength that are so high that they even are comparable to the lower grades of steel. They're comparable of that of the regular everyday mild steel you can get from your hardware stores, while being aluminum alloy, which means it is far lighter than it, which allow you for the same weight to put a lot more and to get more protection basically.
Right. Awesome. All right. Well, thank you so much, Devin. Huge thanks to Devin for sharing his knowledge for this video. You can find a link to his YouTube channel in the description. So let's talk about the plates I made for these tests. Each 6x6 sample of 7075 weighed approximately 0.9 pounds, or 14.4 ounces, at a quarter of an inch thick, so very similar to the weight of porcelain. The goal was to keep the sample plates at around 2.7 pounds, so that way you could make a 12x10 chest insert that would be close to 9 pounds depending on the cut used. There was 7 different plates tested. However, we're only going to focus on 4 of them for the time being to compress the test footage down. Plus, they were the ones that honestly gave the best results anyways. I'll briefly discuss the other ones at the end of the video though. Now, 2 of the 4 was designs submitted to me by members of my Discord group, Mr. Turtle's plate and Arctic Ice's plate. So let's start off with those. Mr. Turtle's plate was comprised of one 10mm thick porcelain tile, one 7075 plate, and 30 layers of S-grade fiberglass and high-strength polyester resin backing it. His plate came out to being right around 2.71 pounds, just shy of the max weight allowance. He also had a specific way he wanted me to wrap the porcelain, using T-Rex tape and doing 2 passes around each section until it was fully compressed both ways. To save on weight and thickness, I didn't add a lot of tape to bind the porcelain to the 7075 and the backer, however, a decision I would later regret. Now, Arctic Ice's plate was virtually the same as Mr. Turtle's plate, having both a porcelain strike face and 7075 as an intermediary. The only difference was the backer, which was a half an inch thick slab of HDPE from a cutting board. Now the other plates were as follows. One standalone plate of 7075, one was comprised of 2 7075 plates duct taped together, one was just porcelain strike face with one 7075 plate backing it. These 3 were mainly a calibration of sorts, just to see what this material could handle against different ballistic threats. And the last one was one 7070 plate with a bunch of laminated Inegra backing it. I wanted to see if it could actually handle rifle rounds as a strike face. So let's go ahead and head out to the range and I'll show you guys the test footage. Alright, so let's go ahead and get on to the ballistic footage. I want to do things a little bit differently compared to some of my other videos, mainly because I want to get as much information to you guys as possible on the conclusions I've come up with from testing these different plates, okay? First up, we're going to just show you the calibration plates and kind of just skim over it because I want you guys to see, though, that it by itself, it can handle pistol rounds. Going into the range, I had no idea how this stuff was going to react. Was it going to pin right through it? Was it going to spall like crazy? So I was a little worried and apprehensive because when you're shooting metal, you have to worry about, ricochets and other stuff. And so initially I just kind of set it up somewhere and shot it and let it fly back. But later I would anchor it into place into the dirt. So you'll see that as it moves on. But everything I shot at it was a full metal jacket. And yeah, I think you guys will really enjoy these initial plates and the ones that we're actually able to stop some pretty impressive calibers. So let's get started on that.
Racket. Oh, he did. He did.
So we shot 1/4 inch, flew way back. There it is. So
It stopped it, huh?
yep. We don't count it, don't worry. There we go. Let's take a look. 9mm. So you can see the difference of depth of impact from a 9mm to a 45 ACP. Honestly, we could test this on ballistic clay. I just expected it to do worse than this.
Well,
This is freaking...
there's no deformation in the back.
Yeah, maybe a very slight dimpling. Yeah.
I don't know what the gear is on.
Alright, so now we'll try some Full Metal Jacket from a 38 Special. Whenever you're ready. Really? Yes, sir. I see another dimple. Where is that the same? There it was. A little high, but it's spalling. You are seeing some lead spall. These are Full Metal Jackets that we're shooting at it though, guys. Let's step it up to the 357 Magnum. We might have to go to rifles to see if we're going to get through this, which is absolutely insane. Nice. This is Full Metal Jackets out of a... How long is the...
Magnum?
Yeah,
6-inch barrel.
And blew it back into it. My gosh. Look at the spalling on it.
Let me try it again.
Yeah, see, so this is the 45. This was, no, that was the 45 ACP, 9mm, 38 Special, all Full Metal Jackets. That was the 357 Magnum Full Metal Jacket. And the cat.
Stand up there again, let's try it again.
The cat lives on, boys. The cat lives on. Alright. Second shot from a 357 mag. Let's get some. Kill. Dang! Or it might have been a piece of metal. Where the heck did you hit? Did you really hit right where that 9 was? Or no, the 9 was lower. You killed the cat.
I killed the cat.
Okay, now let's look at some of the rifle tests. The single layer was unable to stop the 55 grain Full Metal Jacket 5.56, and you can see how easily it passes through the single layer. I then tried the plate that had 2 1/4 inch 775 duct tape together, bumping it up to a 1/2 inch of material, and as you can see, the 5.56 made it through that one as well. I then moved on to the one with a porcelain strike face and 70-75 backing it, and we finally saw the 55 grain 5.56 stopped. However, the M855, also known as the green tipped 5.56 mild steel core, did make it through. Now I'm going to show the next 3 plates together because they were so similar in design, and they gave very similar results. Really, the only difference between Turtles, Arctics, and the polycarbonate plate was the backer. For these 3, plus the last one I just showed, I've drawn quite a few different conclusions. First up, both a 123 grain Full Metal Jacket 7.62 by 39 and a 55 grain Full Metal Jacket 5.56 will stop on the 70-75 if it has an 8 to 10 millimeter porcelain strike face, leaving just a dimple with some cracks in the back of the 70-75. There it goes, hit high, but it stopped. Look at there. Let's take a look at the clay witness. Yeah, that's where all the shrapnel blew up into. Look at that. You can see it. All the lead spray. So the plate was sitting like this, and it shot up out the top. Bottom corner. Bottom corner. Take this out. Did it pass through? It did not make it through. Also, if a shot is placed close to the same area as a previous shot on the 70-75, it will fail, with cracks forming from the previous shot's dimple to the new hole. Of course, the ceramic is also damaged in that area, but it just goes to show how brittle the T651 hardness is, and how it may be a big factor in its failure mode. There also was major spalling issues between the porcelain and the 7075. I noticed this more and more as I was taking the plates apart later. This often caused the plates to blow apart, even though I would add more duct tape to keep them together between subsequent shots. This left large areas of lead and jacket sprayed over the surface of the 7075, indicating that the bullet was disintegrating between the porcelain and the aluminum. This was most likely due to the T651 hardness of the 7075, as I've tested plenty of plates comprised of porcelain and polycarbonate in the past. I've never seen this type of spalling before. I will have to look at urethane coatings and elastomer resins for a possible remedy to this problem. Now, both Turtles and Arctic's plate were able to stop the M855, but just barely. For Turtles, it caught the edge and sprayed up into the clay, which meant it was most likely still a lethal shot, technically. And Arctic's caught in the very back of his HDPE cutting board. So, with some modifications, I really do believe that theirs should be able to outright stop the M855, which is quite impressive. There we go. We see the exit that we're seeing on the aluminum. And... ha! No shit! I also want to note that none of these plates stopped the 149 grain full metal jacket 308, also known as the M80. However, in both the tests where I shot it, the porcelain was already damaged close to the area where the M80 landed, and the impact on the clay was a cone full of lead spray and metal shrapnel. Neither of them blew through the clay witness or out the back, which I do find interesting because if you've seen plenty of other videos I've done, mainly the Myanmar with Love, when I test the 308, it often will just absolutely destroy my clay witness or blow it out through the side. This indicates to me that that 308 was definitely slowing down. Yes, it was still technically a lethal shot, like absolutely, but it lost a significant amount of energy passing through both the porcelain, the 7075, and whatever it had the backer. For the two tests I've done was Turtles and it was the polycarbonate plates, so quite interesting. Alright, so what did I really learn from testing all these plates? Well, first off, I think more experimentation is needed. You know, testing 7 different plates out of this material really revealed some things to me. First off, that hardness is a very interesting thing. You know, like what Devin was saying, I'm kind of curious what happens if we went with a slightly less hardness, like a T4 or T3. Having more ductivity as a ballistic intermediary, like we've seen with HDPE, might actually be beneficial. But being able to stop outright, this is pretty impressive that all you need is a porcelain strike face and this material, and you can start stopping the M193 and the 7.62 by 39 122 grain full metal jackets, right? That's a pretty impressive feat just right out the gate. And that would still be pretty light. Per square foot would be what? 2, 4, 6, 8 pounds roughly. So for vehicle armor, that's not bad. You know, there's definitely going to be more experimentation needed before I conclude, you know, everything about 7075. I just wanted to go and give you guys this. I wanted to go out and shoot some more plates. I have some already because I want to test thicknesses of the T651 as well as a couple other hardnesses. That'll hopefully come in the next few months. Honestly, with my job, it's hard to get out here and record as much anymore, guys. But huge thank you to Devin, to Turtle, and to Arctic. I will definitely be referring to them in the future for the 2.0 of these plates. And hopefully, between brainstorming with all 3 of us, we might be able to come up with even better solutions and keep it even lighter weight. If you want to get into the discussion, head over to my Discord. Armorgate is up and running. There will be a link in the description. And by the way, I also want to mention, because it is the end of the video, check out this drip. So there was a guy who gave me a shout out not too long ago on a meme page, and he makes these really dope shirts. I picked up a few of them and I figured share the love back at him. So head over to his website and pick up some of these types of t-shirts. You'll be seeing a lot more of them on me while I'm recording because I just like the style. If you do too, maybe head over and give him some love. Alright guys, we just hit 10,000 subscribers. I'm excited to show you guys what that's going to be here in the next few weeks. See you guys in the next one. Take care.